Hi, I'm Colin, and today throwing around some ideas on aviation instruments. Now, some of the latest aircraft, the Boeing 787s, the 777s, the Airbus 330s, 350s, have some rather clever new instruments on, so they can electronically measure at any time the air pressure in the tyres and the amount of fuel that's coming onto the plane when refueling. And this information is automatically uploaded onto the computer systems and shared online with their flight centres. Now, this is really good, but a lot more could be done with that information. Now, firstly, on fuel, the reason why this is needed is unfortunately at some airports, the fuel companies will try and cheat the airline. Now, what they'll do is the fuel truck will come up to the aircraft and the gauges are not set at zero. They already have something on them, so that when the engineer checks the amount pumped onto the plane from the fuel truck, it'll say a certain amount, but less has been delivered. Now, traditionally, the fuel gauge inside the plane is only measuring the tanks, and this gets complicated because the density of the fuel will make an impact on the volume of it. So normally there wouldn't be too much difference, but when you're talking about fuel varying massively in temperature, it does make a difference. Fuel could either be at -40 when it's up in the air or +40 on the ground, and if you're pumping tons of it, there is quite a big difference. So currently, usually the temperature sensors are in the fuel tanks themselves. Now this gets very complicated because the tanks, often when the plane has landed, have some spare fuel in at -40, and there are various different tanks. You're putting different temperature fuel in, and it's all mixing together, it's mixing differently in different tanks, and it all gets very difficult to measure. Also, trying to measure the temperature of the fuel on the fuel truck gets complicated as well, because the runway is typically hotter in the summer than its surroundings because of all that concrete, so the fuel is heating up as you're trying to measure it. Otherwise, in the winter, the runway is typically colder than its surroundings because of wind chill. So measuring it as you're pumping it from the fuel truck gets a little bit complicated. Now, the solution is to have a measure at the inlet valve on the wing. So where the amount of volume of the fuel is being measured on the aircraft side, there should be a protruding temperature gauge in there as well to measure exactly the temperature of the fuel as it's coming onto the aircraft. Then you can get an exact calculation. So using the exact temperature the fuel is coming on the plane plus the volume of it, you've then got an exact weight of the fuel and the density calculation automatically that can be measured by the aircraft and shared online, so that any inaccuracies in the past can be overcome using a little bit of maths and the new instrumentation. Now you may ask, why can't the plane just measure its weight as the fuel's coming on? Well, it can't do this because typically as a plane is being fueled, there is people coming on and off the plane, there's baggage being unloaded, there's cargo going on, there's loads of other factors involved, so you can't really isolate how much of the weight change is on the fuel by itself. Now, planes used to have weight measures on the struts of the wheels, but these were always plagued by inaccuracy, and still most airlines are using manual calculations. So you have the empty weight of the plane, the amount of fuel you're putting on, and then assumptions about the baggage and the passenger weight and the exact amount of the cargo. Now, to get the weight and balance of the plane right is very important. It's a safety factor. There's regulations around it, and the distribution of the weight on the plane is incredibly important. Otherwise, you get something like a tail strike when taking off. But this is where the new tyre pressure sensors come in. These are also very, very new. So there's a valve on the tyres, on each tyre on modern aircraft, on the most recent ones, that electronically transmits the air pressure back to the aircraft computer systems. Now, this could be used properly to measure the aircraft weight without any extra instrumentation, just using a bit of maths. So, you have the air pressure within the tyre, and you need to be measuring that anyway for safety. So, for example, if there's a leak during the flight, that you'd know about it. But you can take that pressure and you could be measuring it as the aircraft is at different altitudes, especially just before landing and after takeoff. Now you're compensating for barometric pressure, but you're working out the exact pressure of that tyre without any weight on it. When the plane is then on the ground, you could be measuring all of the pressures, the new pressures with the weight on, of each tyre, and then getting an accurate calculation of the weight of the plane total and the balance of that weight within the different wheels. So this would then be a much more accurate measure without any extra instruments, which would add a lot to safety. So you're not relying on the strut measures anymore, and you're not relying purely on manual guesses of what the weight of the plane is. You're using the existing instrumentation, which is being loaded already onto the computer. The computer just runs some more calculations as a backup, and this would really improve safety and information to the crew. So it's great news that airlines, the new aircraft, do have these new instruments available, which can automatically measure a number of things that weren't measured before. And it's also great that they're having that information available online back to flight centres instantly. But it's what you do with that information. Just run a few more calculations on it. Computer's great at calculating, and you've suddenly improved airline safety considerably.